Okay, so this will be 6.9. Again, finding zeros, kind of the culmination of the whole chapter, putting everything together. So for the little warm up here, this was just a review of a quadratic, just to kind of talk about some of the different options. Um, how could we find all the zeros of something like that? There's a few different ways to do it. Graph it. Just graph it. Okay, so that's probably the best, the fastest way, right? If we have the calculators like we were just talking about, go ahead and graph the thing and look for the two zeros. Okay, and what did it turn out to be in this problem? So the zeros were at -5 and 3, okay? And the graph did something like this. We know it's a quadratic. Okay, so that's a kind of a good way to do this. Is there ever a time when graphing will not get you the zeros, though? Yeah, if they're imaginary, okay? So graphing will always get them if they're real, but if they were not real, if they were imaginary, you might want to go quadratic formula. Okay, or of course factoring is another option, and factoring is going to work if they're real. Um, but just a couple different options. So again, this chapter is all about solving equations like that, but again, bigger ones, polynomials. Okay, x third degrees, fourth degrees. We'll probably stick with those, even though they could be larger. The process we're about to do will work. Um, but I just wanted to make sure we see the connection. It's just like solving quadratics. Okay, so let's look at a couple examples. I have two examples. Okay, that's just homework, other homework. Okay, so let's kind of recall this was something from a previous section that we're going to use a little bit. I think this was in 6.8 if I remember. If they give you, or if you know the zeros, okay, like you know the answers, okay, could we come up with the equation somehow? Or what do we know? So we were thinking something about if 2 is a 0, we know something about x minus 2, right? Because wouldn't that factor get 2 as an answer? And then if we know -4 is a 0, what's the other factor? X plus 4. So we know that both of these are factors of the equation. Okay, now the thing is, we don't know for sure if those are the only factors. Okay, what we have with two factors there, that would mean this thing is a quadratic, it's a parabola. Okay, but isn't it possible that this graph goes like, does a whole bunch of weird stuff, and it just has the two zeros that we know, right? Here's the 0 we know, here's another one. We don't know that this thing is a quadratic. Maybe this could be what, it has 1, 2, 3, 4, 5. This has 5 turning points. It could be a 6th degree function or something. We don't know. We just know it has two real zeros. So we just know for sure that these two things are factors, but we don't know if they're all of the factors. There could be other factors making this thing a 6th degree or even higher. Okay, so what we're going to do is just kind of use the fact that we at least know some of the factors. Okay, we might not know them all, but we at least know the ones that come from the zeros given. Okay, and that'll come up in a little bit here too. Okay, so let's get to the new stuff of actually solving an equation. Okay, let's find all the roots or zeros of this equation. Okay, and let's pretend like we don't have the calculator where we can just throw it in, because again, there's no guarantee that the calculator is going to show them all. Okay, sometimes they will, sometimes they won't, but let's kind of see if we can do this the old way, you know, how they used to do things before there were calculators, by just factoring. Okay. Yeah, like do grouping. So what if we tried to group the first two? Usually with grouping 2 and 2. You want to group that one too. Usually it's going to be 2 and 2 because you're going to need some common factor in the second group. Mm-hmm. So you're saying take the x out of the first three? Because you will still have the plus 12 sitting there, so that's, I think, the problem. If we had this, as long if you kept the plus 12 there, but see, it's still not like factored. And I think what some of you guys are seeing, even if you group it the way we always did, it's still not going to work, I don't think. Because if we group it, right, the first two, they share x squared, right? So x squared, and then x minus 7, right? And grouping is usually the method when there's four terms. That's why I tried this. So if we tried that second group, we notice they do have a common factor of 4, but the leftover factor here is not matching up with the first one. They're not the same, so there's no common factor. We can't like bring anything out front. So this kind of didn't work. Okay, so some problems you're going to have to do this. This time it just didn't work. Okay, so we have the other option, and usually, since you guys all have calculators available, graphing is going to usually be the first thing you're going to want to do. Okay, if that doesn't work, then you can try other things, because again, graphing doesn't always show, it never shows imaginary ones. But let's graph this thing, and let's see if that gets us any of the zeros. Okay, and while we're doing that, why don't we list some of the possible rational zeros, or list all of the possible rational zeros, just so we know which ones to maybe look for. Okay, so what are the possible rational zeros? Okay, we need factors of 12, right? So plus or minus 1. Don't forget 2. 3 goes into 12. 4 goes into 12. 6 and 12. Okay, and in this case, the denominator would be the factors of the leading coefficient. If that's ever just a 1, dividing by 1 is not going to change anything. So there's your list. Okay, and again, in the old days, before calculators, what people would do, or what we have to do, is you would have to check, like, let's try one. If I plugged positive 1 in for all of these x's, let's see, does it get me a 0? Maybe it does, maybe not. Let's try negative 1. Does it get me a 0? Maybe not. So that's what this little process was for. Um, let's just graph the thing, though. We have the technology available. Let's see and look for, are any of these shown on the graph as zeros? Okay, so go ahead and get a graph of it. And, and let me know, do we see any of the things in this list? Okay, and while we're doing that, how many total zeros should we expect here? 3 total zeros. So know that ahead of time too. So if we see 3 on the calculator, we're done with this problem. There's 3 total because that's the degree. So what's this graph look like? What's it go through? Yeah, I think you should go through 3 nice whole numbers. What'd they go through? Negative 1. Okay, and they kind of come up, something like that, roughly. Okay, so this one was kind of nice, where all of the answers were nice whole numbers. Okay, or I should say integers, because there's a negative whole number in there. Are they all in this list? Yep, we had negative 1, 2 was in the list, 6 was in the list. So they were all nice there, right there for us. Okay, we didn't have to do any like manual work. So as far as showing work on a problem like this, you can show me a graph, and it doesn't have to be super accurate, just like the one I drew, just to show the zeros. Or you can even just draw me a little part of the table. Okay, like you could show me an XY table and show me when X was negative 1, the Y value is 0. That'd be a good way to check your work on your calculator. Pull the table up. Show me when X was 2, the Y value was 0. And when X was 6, the Y value was 0. So that's all the work I would need to see on that. Okay, so this one's really not a lot going on. The calculator makes this much easier for us. Okay, so again, the calculator did all the work that one. Let's do Let's look at one other one. Okay, there's going to be times when you have to do a little more work. And these, as we go through this, I want you guys to think about the thought process. Don't try to just memorize steps. There's going to be a lot of steps in this one. But if you think about what we're doing, I think you'll see the connection to old stuff, like basic arithmetic stuff. You'll see comes into play here. Okay, so this one, all roots of, I just call this one g of x, x to the fourth plus 2x cubed plus 2x squared minus 2x minus 3. Okay, so this one has a total of 4 zeros. So knowing that ahead of time is helpful. Okay, and why don't we look at the graph and see if we can get any right away. So look at the graph. And let's see if there's any rational zeros, and you'll see why we want them to be rational in a second. It's going to be a lot easier to do the calculations we need to do. So that's where you can refer to your list if you have a little list of the possibilities. Okay, remember the possibilities in this example are going to be plus and minus 1 and plus and minus 3. Okay, so let's look at that graph and see if any of those work for us, or maybe all 4 of them do, and we'll be done again. But I have a feeling this one's not going to work out as nice, because I planned it that way so it wouldn't. We just named it G instead of F, no reason. Okay, so I have this thing graphed. Looks like that. Okay, so it appears to me that there are a couple zeros, a couple real zeros showing up. And it looks like that might be a -1 and a 1. Okay, so again, let's make sure that those really are the nice whole numbers. Make sure it's not something just close to 1 or something. So you can check by looking at your table. Or we can, there's another way, if you remember, you can use the trace button. And moving the arrow, you can get close to it, but even better, once you press trace, just type an x value. If you type -1 and press enter, it's going to give you the y value, and you'll be able to see that the y value really is 0 there. Okay, so -1 is one of our answers. Okay, it looks like +1 is. Let me type 1, +1, press enter, and there's another one. So those actually are 2 of the 4 answers. -1, +1. Okay, so here's where it gets a little more involved. Okay, so the graph showed -1 and +1. Okay, so we have 2 of our 4 answers. Okay, the other 2, if they're not showing up on the graph, must be imaginary. Okay, so we need to find those. So here's the thought process. Okay, think about the little recall I had you guys do a second ago. If x equals 1 is a 0, what do we know must be a factor? If x equals 1 is a 0, what must one of the factors be? If x equals something is a factor, what must, or a 0, what must one of the factors be? X minus 1? And the other one, if x equals -1 is a 0, x plus 1. Okay, so we know 2 of the factors of this thing, right? Okay. All right, so think about this now. We know. Okay, remember the big original thing was called g of x, right? So g of x, we know that it is x minus 1. That's one of the factors. X plus 1 is another one of the factors. There's some other unknown factor out there that we don't know. Okay, That's where the other zeros are going to come from. Okay, but we know two of the factors. Okay, here's another thought. Okay, we know there's four total zeros. Okay, we have two of them. Okay, so we have two zeros. So we know two factors. Okay, again, there are four total zeros from the beginning. Okay, so this other factor, like this missing piece, is going to give us two more zeros. So it's probably a quadratic. Okay, that's how we get two zeros from a second degree. Okay, it's either that or it's going to be two single first degree things like, but it's going to be a quadratic. Okay, we need four total zeros. Here's how we find that missing piece. Let me go to a new page here. Think about this. What if I told you, oops, you don't want to know that yet. All right, if I said something like 60 equals 2 times 3 times some missing piece. Okay, this is the exact same format of what we have. Okay, how could we find out what goes in the missing box? Okay, we could either multiply these first and get 6 times something and then divide the 60 by 6. Okay, or what you were going to say the first time, I think, couldn't you divide by 2, then divide that new answer by 3, like divide twice? Okay, that's exactly what we're going to do, because what goes in the box would be 10, right? Okay, we are at this exact same step right here. Okay, we have some big thing. Okay, remember, g of x is the original function up here. Okay, we know that it equals something times something times something else. Okay, so to find the something else, we can divide the big G of x first by this, and then by this. Division problems. Okay, so here's your options. Okay, two options. You can either do it like I said, do them one at a time. And honestly, I think that's going to be the way to go, because if you guys remember, and we'll review this, dividing by this, you can use synthetic division and do it in like 10 seconds. Okay, and then we'll divide the new thing by this synthetically again in like 10 seconds. Okay, your other option is, like for this example, you could multiply the two things together and get a new number and just do one division problem if you want. That would, in this problem, that would involve multiplying these two things together and then using long division. Okay, so I'm going to do the synthetic way. I think it's a little bit more straightforward, a little easier. So let's do that real quick. Okay, so let me rewrite g of x was x to the fourth plus 2x. Okay, so just to see where we're at, x to the fourth plus, what was it, 2x cubed? It was 2x squared. Okay. Okay, again, we know it equals this. Oops, we had the minus first. It doesn't really matter the order, but times this, times some other piece that we don't know yet. So what I'm going to do first is divide by this. Okay, is that the right thing? Minus 2x minus 3 in there? Yeah, sorry. Okay, so let's divide both sides by the x minus 1 factor first. Let's get rid of that. Okay, we're going to do this synthetically. Much, much easier. If you want to do long division, go for it. But synthetically is kind of a lot quicker. So how would we divide synthetically? If we're dividing by this, what goes in the box? Or the 1 goes in the box. Then list the coefficients, right? So we got a 1x to the fourth, 2x to the third, 2x squared, negative 2x, and a minus 3. Okay, and then you have your synthetic process. Okay, we're going to bring the 1 down and go from there. Okay, and we're going to multiply 1 by the 1 to get 2. Or I'm sorry, to get 1. I'm a step ahead here. 2 plus 1 is 3. And then we multiply the 3 by the 1 to get 3. 2 plus 3. 5 times 1. Negative 2 plus 5. 3 times 1, remainder 0. Okay, and it better be a remainder of 0 because we knew it was a factor. If it's not 0, you did something wrong. So the remainder is 0. Okay, so that's good. So what I did was I took our big g of x and I divided one of the factors out of it. Okay, we started with the 4th degree. Our synthetic answer is the coefficient of a 3rd degree. Okay, so that's x to the 3rd plus, right, 3x squared plus 5x plus 3. Okay, yes. Okay, so now what we did, now we're to the point where we have a 3rd degree, and we need to divide that now by the other factor that we haven't divided by yet. Okay, this is the 2nd division part. Like with the 60, remember we divided by 2, and then we divided by that answer by 3. That's the step we're at right now. Okay, so let's do that synthetically. Let's take this thing and divide it by the x plus 1, and that'll give us our remaining factor that was the question mark that we didn't know. Okay, so you kind of take your answer and divide it again. So synthetically with that one, we would use a negative 1 in the box. Coefficients again are 1, 3, 5, 3. Okay, and we're going to go ahead and do synthetic. Bring down the 1. Right? And we're going to multiply 1 by negative 1, and then we add straight down to get 2. Multiply it by the negative 1. Add straight down. Multiply. And again, it better be 0. It better go in evenly if we knew it was a factor from the beginning. Okay, that is our other factor. Or that is the coefficients of it. X squared plus 2x plus 3. Okay, so let's get everything organized here. Okay, remember our original big function, g of x. Okay, we factored it now. Okay, we knew from the very beginning that x plus 1 and x minus 1 were 2 factors from the beginning graph, right? We just found the other factor is this. Okay, that's completely factored, as much as we can go. Okay, so our answers were the negative 1 from the beginning, the positive 1 from the beginning. The other 2 are coming from this piece. And what method are we kind of locked into? You can try factoring, but probably quadratic formula because they're imaginary. The graph didn't show them. So you're going to have to throw a quadratic formula to finish this up. Okay, so let's do that real quick. Just about done. And again, they are long problems. It's a complicated thing. You're solving a 4th degree polynomial. Our original goal, remember, was to find all of the zeros of this original thing. Right, and we found 2 of them from the graph at the very beginning. So now we're able to get the other 2 from this last piece. Okay? All right, so let's finish this up. So x equals opposite of b, so negative 2, right? Plus or minus, big square root, b squared minus 4ac, all over 2a. Okay? Yep, quadratic formula. Okay, and if we just simplify that, we'll get our answers and finally finish this problem. Okay. All right, so what do we got under square root? 2 squared, so 4 minus 12. 4 minus 12, so negative 8. Okay, see how it's going to be imaginary? Okay, because the discriminant's negative. That's why the original graph didn't show these, because they are imaginary. Okay, so I think the root negative 8 is really just 2I root 2 if you check the breakdown on that from a couple chapters ago, right? And then finally our one last step of reducing. The coefficients are all divisible by 2. So if we divide all those by 2, we'll get negative 1 plus or minus I root 2. And there's your other two answers. Okay. And then of course from earlier, the negative 1 and positive 1 are also the other two. So there's your total of 4 answers. Okay. Hope you guys write small, had a lot of paper. Long problem.